100,000 years ago, our planet was a very different place. Back then, Earth was slowly becoming colder, having entered the last glacial period about 15,000 years before then. Some parts of the northern hemisphere were already buried in ice and snow, creating a vast, cold wasteland that swallowed parts of North America, Europe, and even some of Asia. Across these snowy lands roamed herds of giant megafauna, along with small bands of archaic humans, all competing to survive in this cold, unforgiving world. This episode in our planet's history took place during a long period of global cooling, known as the Quaternary glaciation. It began about 2.58 million years ago, at the start of the Pleistocene epoch, and is technically still happening today. Within larger ice ages, our climate cycles between two primary states: cold glacial periods and warmer interglacial periods, like the one we're living in now. During glacial periods, temperatures generally decrease and the world's glaciers expand. The opposite happens during interglacial periods. The climate becomes more temperate, so glaciers tend to recede toward the poles. This glacial-interglacial cycle alternates about every 100,000 years, based on small changes in the orbit and position of our planet. For example, when the shape of Earth's orbit is more eccentric, it changes the distribution of solar radiation across the planet's surface. During the last glacial period, global temperatures were lower than they are today. Cold streams of air whipped across our continents. Winter seasons were long and harsh, especially in the northern hemisphere, where massive ice sheets gradually advanced from high-latitude regions. The Laurentide ice sheet, one of the largest ice sheets during this period, expanded across most of modern-day Canada and large parts of the United States. At its peak, around 23,000 years ago, the southern margin of the ice sheet covered present-day Boston, New York City, and Chicago, and extended even further south in some areas. When glaciers expand, they freeze the landscape and sculpt new features like U-shaped valleys, fjords, and elongated hills known as drumlins. They also cause significant changes to our planet's natural water cycle. Normally, water evaporates from sources like the ocean, and then rises, cools, and condenses into clouds before falling back to Earth's surface as rain or snow. During the last glacial period, much of that water became trapped in continental ice, causing a dramatic drop in sea levels. The receding of the oceans exposed continental shelves and created new land bridges, like the Bering Land Bridge between Asia and North America. These disruptions also had a profound effect on terrestrial ecosystems. During the last glacial period, many regions experienced a significant drop in rainfall, such as Northern Africa and South America. With less precipitation, tropical and temperate ecosystems like rainforests and wetlands began to shrink and fragment. While the tropics contracted, cold and dry environments expanded across the northern hemisphere, growing an enormous biome known as the Mammoth Steppe. This biome actually began far earlier, during the Middle Pleistocene, as tundra and steppe environments across Europe and Asia merged into a unified ecosystem. Over many glacial periods, the Mammoth Steppe expanded to the east and west, eventually crossing the Bering Land Bridge into modern-day Alaska and Canada. By the time our planet entered the most recent glacial period, the Mammoth Steppe was the largest terrestrial biome on the planet. Despite its staggering size, the Mammoth Steppe was fairly consistent. It was a mostly flat and open environment with rolling hills and rivers scattered throughout. Rain was less common across this dry biome, making it a challenge for trees to flourish there. Instead, the Mammoth Steppe was dominated by many types of tolerant grasses. These species were well adapted to growing in dry soils and thrived during glacial periods, along with shrubs, herbs, and terrestrial mosses. In a cold ecosystem like the Mammoth Steppe, we might not expect to find much wildlife, but this biome supported an incredible diversity of animals, including some iconic Ice Age megafauna. Reindeer, muskox, and the ancestors of modern bison were just a few of the massive herbivores that roamed these spacious grasslands. Significantly more megafauna lived in tundra steppe environments compared to today, leading to a great variety of Ice Age mammals. Perhaps the largest and best-known herbivores in the Mammoth Steppe were the giant, shaggy relatives of modern-day elephants, called woolly mammoths. These huge animals stood up to 3.4 meters at the shoulder and weighed up to 6 metric tons, rivaling the largest elephants in Africa today. To support their massive frames, woolly mammoths needed a lot of food to survive. A single mammoth ate about 150 kilograms of plant matter per day. Luckily, these animals were well adapted to foraging for food. During snowy seasons, they used their trunks and tusks to sweep aside piles of snow, revealing edible plants that other animals might have missed. Giant herbivores like woolly mammoths played important ecological roles in the mammoth steppe. Their feeding habits dispersed seeds and moderated dominant plant species, while their heavy footsteps shaped the landscape, creating pathways used by other migratory animals. These herbivorous megafauna also played a supporting role, providing food for the many deadly predators in the mammoth steppe that specialized in hunting big game. Among the most powerful predators of the time period was Panthera atrox, also known as the American lion. This giant cat was closely related to modern lions, but was significantly larger, reaching around 3 meters long if you include the tail, and weighing over 350 kilograms for larger males. Throughout the last glacial period, American lions dominated grasslands in and around the mammoth steppe, and fared well in several other ecosystems too, including southern regions such as Mexico. Their diet consisted mostly of large grazers and browsers, like horses, steppe bison, and camels. During their long reign, American lions likely crossed paths with another powerful predator, known for its long, blade-like teeth. Smilodon fatalis was a saber-toothed cat, with a more robust and muscular frame than most big cats, weighing up to 280 kilograms for the largest males. When hunting, Smilodon fatalis used its powerful body to tackle and pin down large herbivores. It then delivered a killing bite with its humongous canines, which grew up to 18 centimeters long, far larger than those of modern big cats. The mammoth steppe was extremely biodiverse during the last glacial period, supporting many extraordinary life forms. But it wasn't the only biome fostering rich and active ecosystems. Beyond the mammoth steppe, parts of Eurasia and North America were covered by boreal forests, filled with coniferous trees like spruce, pine, and firs. Snow was common in boreal forests, so many animals in these regions adapted specialized physical traits. Hares, for example, avoided predation by blending into the snowy forest floor, while large elk used their long legs to navigate areas covered in snow. Boreal forests sprouted up in colder regions, on the fringes of tundras and steppes, but there were also temperate areas with milder climates and more distinct seasons. These regions sometimes experienced rainfall, so temperate flora like deciduous trees could grow there. Along with smaller plants and underbrush, these trees provided critical habitats for the many kinds of animals that couldn't survive in colder, drier parts of the world. Straight-tusked elephants, for example, lacked the same layers of fur and fat as their woolly relatives. Instead, they were adapted to milder forests, woodlands, and grasslands. 100,000 years ago, many of the planet's warmest ecosystems were located around the equator, including northern Africa, the Middle East, and parts of Asia. Some of these regions were dry, but there were also more tropical biomes like savannas and woodlands. During interglacial periods, these environments tended to be warm and seasonally wet, making them hotbeds for animal evolution. However, during glacial periods, the planet's savannas generally became colder and drier. Still, these ecosystems were home to many types of animals, including early humans, who were gradually becoming highly successful predators. 100,000 years ago, early members of our species, Homo sapiens, were living in African savannas and woodlands. The first members of our kind lived in regions like modern-day Ethiopia and Morocco, but over time, they spread to distant regions across the African continent. Back then, our ancestors lived in small nomadic bands and depended heavily on their environments for food, water, and shelter. Of course, Homo sapiens were not the only hominins living on our planet 100,000 years ago. Another group of archaic humans called Neanderthals were widespread across Europe and Western Asia. Neanderthals had fairly similar diets, behaviors, and physical traits to Homo sapiens, but they primarily lived in colder biomes, like the mammoth steppe. They possessed stocky and muscular bodies with shorter limbs, which helped them conserve heat in colder climates. They were also masters of fire, often relying on campfires to cook food and stay warm during long winter nights. This glacial period finally came to an end about 11,700 years ago, at the start of the Holocene epoch. By that time, the Neanderthals had long since disappeared, along with many iconic Ice Age animals. Since the Holocene began, temperatures have risen and glaciers have receded toward the poles. We're now living in a warmer period of Earth's natural climate cycle, and life on our planet continues to transform. In another 100,000 years, the world may be stranger than we could possibly imagine.